All right, today we're talking about something that was a total game changer in the world of AI. It's a model that completely flipped the script on how machines understand human language. And it did it with a trick that's so simple, we humans do it without even thinking. It learned to read the whole sentence at once. So let's get into the story of BERT.
So I want you to imagine this. Try to read a sentence, but you're only allowed to see the words that came before the one you're currently on. No peeking ahead, no seeing where it's all going. Sounds kind of impossible, right? Well, that is the exact problem that early language models were stuck with. They were on a one-way street, and it was a huge, huge handicap.
And this slide just perfectly illustrates the difference. On the left, you've got the old way. A model sees "the cat sat on the," and it has to guess. It could be mat, chair, floor, who knows? But now look at the right. The new, bidirectional way sees the whole thing. When it also sees that the sentence ends with "and purred," well, the guess gets a whole lot easier, doesn't it? It uses clues from the future to make sense of the past.
So yeah, for any AI trying to understand language, context is absolutely everything. And seeing only half of that context, it's like trying to solve a puzzle with half the pieces just gone.
You know, models like the original OpenAI GPT were super powerful for their time, but they were built on this rigid left-to-right architecture. Every word could only pay attention to the words that came before it. The original paper on BERT even calls this suboptimal for understanding whole sentences and says it can be very harmful for things like question answering, where you have to know the full context to get the right answer.
So how do you fix this one-way street problem? Well, in 2018, researchers at Google introduced a model that could finally look both ways, and they called it BERT. Okay, BERT stands for Bidirectional Encoder Representations from Transformers. It's a mouthful, I know. But the only word you really need to focus on is bidirectional. Unlike everything that came before, BERT was built from the ground up to process the entire sequence of words all at once, from its very first layer to its last. It's looking at the context from the left and the right, simultaneously. It sees the whole picture, all the time.
But wait a second, this kind of brings up a problem, right? If a model can already see the word it's trying to predict, wouldn't it just cheat? Well, this is where the training process gets really, really clever. Turns out BERT learns by playing two simple but totally brilliant games.
The first game is basically a super advanced version of fill-in-the-blanks that you might have done in school. The second is a logic test to see if it understands how two sentences relate to each other. And it's these two tasks, together, that give BERT its incredibly deep contextual understanding of language.
Okay, so the first task is called the Masked Language Model, or MLM for short. It's brilliant in its simplicity. You give the model a sentence, but you randomly hide one of the words, replacing it with this special mask token. The model's only job is to use the context from both sides, the words before and after the mask, to guess what that hidden word is. This forces it to build a really rich bidirectional map of how language works.
Now this is where it gets really smart. The researchers knew that if they only used the mask token, the model might get lazy and only learn when it sees that specific tag. So they threw in a twist. Of the 15% of words chosen for the game, 10% of the time they'd swap it with a totally random word, and another 10% of the time they'd just leave it as is. This forces the model to pay attention to every single word, because any one of them could be wrong or could be the one it has to predict. Super clever.
And then there's the second game, next sentence prediction. Here, BERT is given two sentences, A and B. It has to figure out, does sentence B logically follow sentence A? Or is it just a completely random sentence pulled from somewhere else? This teaches the model to understand the relationship between sentences, which is a critical skill for things like understanding conversations or finding answers in a long document.
So you've got these two really smart training games that give BERT this new kind of language superpower. But the real question is, did it actually work? Oh yeah, let's look at the results because they weren't just good, they were absolutely revolutionary.
First up, the GLB benchmark. Think of it as like a decathlon for language models. The previous best, OpenAI GPT, scored a 75.1. The basic BERT model beat that. But the bigger version, BERT Large, got an 82.1. That's a 7-point absolute improvement. Now, in the world of AI research, a 7-point jump it's just a massive leap forward.
And it gets even crazier when you look at the Stanford Question Answering Dataset, or SQUAD. On the really tough version, SQUAD 2.0, where the answer might not even be in the text you give it, BERT improved the state-of-the-art score by 5.1 points. Just an incredible demonstration of how well it could truly understand context.
And this is the slide that really made everyone's jaws drop.
On the Squad 1.1 test, a group of BERT models working together didn't just beat the other top AI systems. It scored a 93.2, which actually surpassed the estimated human performance of 91.2 on the exact same task. For the very first time, a machine could read a passage and answer questions about it better than a person.
Look, the crazy high scores were one thing, but BERT's real, lasting legacy, that's arguably even more important. It fundamentally changed how people even thought about building these language AI systems.
It all comes down to this idea of fine-tuning. Before BERT, you often had to build these really complex, specialized models for every single different task. BERT changed all that. Now you could just take the huge, pre-trained BERT model, which already knew so much about language, and just add one tiny, simple layer on top of it. Then, with a little extra training, you could adapt it to a brand new task and get state-of-the-art results. It made high-performance AI so much more accessible. So, if we boil it all down, what did BERT really give us? Well, first, it proved beyond a doubt how incredibly powerful looking at context from both directions really is. Second, it showed that you could use one giant pre-trained model for tons of different things, which saved a ton of work. And finally, the results speak for themselves. It pushed the state-of-the-art forward on 11 different NLP tasks, basically setting a new standard for the entire field.
BERT's success leaves us with this incredible question, doesn't it? Its biggest innovation was, at its core, really simple. Just look at a problem from all the available angles. Use the past and the future to understand the present. It really makes you wonder, what other huge problems could AI solve if we just teach it to see the whole picture?